all is going to be taken apart in a couple days. So we just wanted to make a video to show it's what it did in the field, because this is a very unique robot. This was last year's robots that we built, and its object was to get the debris onto a mountain. Use the servo to help lower the sweeper, so then we could catch debris, which we would use in this. This is our lovely mascot. The controls would sit up here. What are the batteries? The battery would sit up there.
Yeah. Pretty much where the goat's sitting is where all of our electronics used to be, if we can turn this over. You can see there's some remaining wires, like these. And if you look at our unique drivetrain, this drivetrain was dual purpose to be speedy and fast on the field, while being able to climb up the mountain, so it can use its purpose of dropping the debris into the high, middle, and low goals. So if you can see here, for our drivetrain we used 3 wheels that overlapped. We used wedge top tread on Andy Mark Performance wheels to help us climb up the mountain easier. So for this last year, for rescue, we went through many different types of drivetrain. Actually, fun fact, this robot went through 9 different drivetrain changes, and this is the final design. As you can see right here, we decided to use a chain drive, and it would be controlled by 2 motors here and here, and they'd all be connected together. When it came to climbing up the mountain, it would fall over. So to prevent this, we used these washers and mounted them into our Tetrix channel, so it can be as a counterweight for our robot, so that it can be easier to climb.
We have a 2.5 pound weight right here to help counterbalance the weight on the front
as well. So our arm had to carry up to 5 blocks, and we needed a stiff arm to help carry our arm up the mountain. So we decided to use a 9-to-1 gear ratio, so that the arm can be stiff and very strong when it came to holding it up. Because in the past, before we had the 9-to-1 gear ratio, the arm would start to lower down instead of staying up in a still position. Also, another cool thing about our robot is how we wanted it to dump in the middle bucket. So what we did is we used a rev servo powered by this little gear, and it would turn this large gear over side, so the arm can tilt side to side, so that it can dump the blocks into the bucket. There's a 7-to-1 gear ratio on these Actibotic gears, and it's really cool. We need to attach this Actibotics channel to the Tetrix channel, so it's kind of a little bit hard to see, but this flat piece right here in between the Actibotics and Tetrix channel is a custom-made piece.
We have a servo inside of a servo block, which controls the flag right here, which would release the climbers going down to the mountain.
Our intake sweeper is made out of PVC and surgical tubing, and is also helped attach with rev extrusion. We also use 3D printed parts like these, like this one right here, and this one over here, and so on, to help connect the PVC pipes together to the rev extrusion. Also, we used 3D printed parts to help hold our phone, as well as hold wiring, such as these USB cords, like this one right here, to keep our plugins stiff and strong. We also have 3D printed parts on our train drive. Bye, Apollo. We miss you so. That's all. Bye, Bot Buddies.